The National Electrical Code, commonly referred to as the NEC, does not explicitly prohibit the practice of running feeders and branch circuits within the same conduit. However, the NEC does emphasize the importance of maintaining separation between feeders and branch circuits whenever it is practically feasible to do so. To better understand the requirements and guidelines regarding this issue, it is essential to refer to specific sections within the NEC. Section 300.3c addresses conductors of different systems, circuits, voltages, or current ratings and states they should not be installed in the same raceway unless separated by barriers. Similarly, Section 300.3d covers conductors of different systems, circuits, voltages, or current ratings and states they should not be installed together in a cable or raceway without an overall metal covering unless they are identified. These sections, while not explicitly forbidding the commingling of feeders and branch circuits in the same conduit, strongly suggest that such separation is preferable. This preference is rooted in the fact that feeders typically handle higher current levels compared to branch circuits. When feeders and branch circuits are placed in close proximity, it can potentially lead to overheating and other safety hazards. Despite the general recommendation for separation, the NEC does acknowledge some specific exceptions where feeders and branch circuits may be allowed to share the same conduit. One instance is when a feeder and a branch circuit are housed within a single enclosure, such as a panel board. Another exception is when a feeder and a branch circuit are routed through a dedicated wireway that is clearly labeled and segregated for this purpose. Additionally, if the conduit used is rated to handle the maximum current of either the feeder or the branch circuit, it may be acceptable to run both through the same conduit. It is generally considered good practice within the electrical industry to maintain separation between feeders and branch circuits whenever possible. This practice significantly contributes to preventing electrical hazards and greatly simplifies the process of troubleshooting and repairing electrical systems. Therefore, when designing or installing electrical systems, it is advisable to avoid running feeders and branch circuits in the same conduit unless one of the aforementioned exceptions applies. This approach enhances overall safety and makes system maintenance more manageable. Consider an example of a commercial building that requires both high amperage feeders for the main power distribution and lower amperage branch circuits for lighting and receptacle circuits. If the design were to consolidate all these conductors into the same conduit runs, the potential for heat buildup within the conduit increases significantly, particularly under heavy load conditions. This heat can degrade the insulation of the conductors over time, leading to short circuits, ground faults, and potentially electrical fires. Furthermore, troubleshooting becomes exponentially more difficult. Imagine trying to isolate a faulty branch circuit within a conduit bundle containing numerous feeders. The electrician would have to carefully trace each conductor, potentially disrupting power to critical equipment. By keeping the feeders and branch circuits separate, the electrician can quickly identify and isolate the problem circuit without affecting the operation of other essential systems. Firstly, the separation of feeders and branch circuits allows for better heat dissipation. Feeders carrying high currents generate more heat. Separating them from branch circuits reduces the overall temperature within the conduit, prolonging the lifespan of the conductors and reducing the risk of insulation breakdown. Secondly, separate conduits reduce the risk of electromagnetic interference. High current feeders can induce voltages in nearby branch circuit conductors, potentially causing malfunction or damage to sensitive electronic equipment. Thirdly, maintaining separate pathways simplifies future modifications and expansions. As the electrical needs of a building change over time, it becomes easier to add or reroute circuits without having to disrupt existing systems. Fourthly, troubleshooting is significantly easier when feeders and branch circuits are segregated. A fault in one system does not necessarily affect the other, making it easier to identify and isolate the problem. Fifthly, adherence to the principle of separation often results in a more organized and professional installation, which can improve safety and reduce the likelihood of errors. Now, consider the specific NEC references mentioned, Section 300.3c and Section 300.3d. These sections are crucial in understanding the intent of the code regarding conductor management. Section 300.3c specifically uses the term raceway, which includes conduits, tubing, and other channels designed to hold electrical wires. The requirement to separate conductors of different characteristics by barriers implies that the NEC recognizes the potential hazards associated with mixing different types of circuits. These barriers could be physical dividers within a wireway or separate conduits altogether. Section 300.3d reinforces this concept by addressing the installation of different systems within a cable or raceway. The requirement for an overall metal covering or conductor identification highlights the need for a clear distinction between the circuits. This identification is essential for safety and maintenance purposes. The exceptions mentioned in the original guidance should be carefully considered. When a feeder and branch circuit are contained within a single enclosure like a panel board, they are inherently in close proximity. However, panel boards are designed with specific spacing and insulation requirements to mitigate the risks associated with this arrangement. Similarly, dedicated wireways that are clearly labeled and segregated provide a controlled environment where feeders and branch circuits can coexist safely. The key is proper identification and physical separation within the wireway. The exception that allows feeders and branch circuits in the same conduit if it is rated for the maximum current of either circuit requires careful calculation and consideration. The conduit must be sized appropriately to handle the combined heat load of both circuits without exceeding its temperature rating. This typically requires using a larger conduit size than would be necessary for either circuit individually. Furthermore, the ampacity of the conductors must be derivated according to NEC tables to account for the increased ambient temperature within the conduit. To further clarify the practical application of these rules, let's delve into specific scenarios and examples. Imagine a small retail store that requires a 200 amp feeder for general power distribution and several 20 amp branch circuits for lighting and point of sale systems. Ideally, the 200 amp feeder would be run in a separate conduit from the 20 amp branch circuits. This would ensure optimal heat dissipation and minimize the risk of interference. However, if space constraints make it difficult to install separate conduits, the electrician might consider using a larger conduit that is rated for at least 200 amps and varying the ampacity of the conductors accordingly. The electrician would also need to ensure that the conduit is properly grounded and bonded to provide a safe path for fault current. Another scenario might involve a manufacturing facility with heavy machinery requiring large feeders and numerous control circuits operating at lower voltages. In this case, it is even more critical to keep the feeders and control circuits separate. The high currents associated with the machinery can generate significant electromagnetic interference, which can disrupt the operation of the control circuits and potentially lead to equipment malfunction or personal injury. Furthermore, the feeders for the machinery may be subject to harmonic currents, which can exacerbate the heating effect within the conduit. In such a situation, the electrician should consider using metallic conduits to provide shielding against electromagnetic interference and should carefully calculate the ampacity of the conductors to account for harmonic currents. To provide a comprehensive understanding, it is essential to refer to the relevant tables and sections within the NEC. Table 310.15b16 provides the allowable ampacities of insulated conductors based on their temperature rating and the ambient temperature. Table 310.15b3 provides adjustment factors for ambient temperature when conductors are installed in raceways or cables. Annex B provides examples of ampacity calculations for various installation conditions. Section 310.15 outlines the general requirements for conductor ampacity. Section 314 covers outlet boxes, conduit bodies, and pull boxes. Section 344 covers rigid metal conduit. Section 348 covers electrical metallic tubing, commonly known as EMT. Section 350 covers flexible metal conduit. Section 352 covers rigid polyvinyl chloride conduit, commonly known as PVC. Section 356 covers liquid tight flexible non-metallic conduit. Section 358 covers electrical metallic tubing, commonly known as EMT. Section 362 covers electrical non-metallic tubing, commonly known as ENT. Section 376 covers metal wireways. Section 386 covers surface metal raceways. Section 388 covers surface non-metallic raceways. In addition to the NEC requirements, it is also important to consider local building codes and regulations, which may have additional requirements or restrictions regarding the installation of feeders and branch circuits. For instance, some jurisdictions may require the use of specific types of conduit or may limit the number of conductors that can be installed in a single conduit. Moreover, it is crucial to adhere to industry best practices and standards. Organizations such as the Institute of Electrical and Electronics Engineers, commonly referred to as the IEE, and the National Fire Protection Association, commonly referred to as the NFPA, publish guidelines and standards that provide valuable information on electrical system design and installation. These standards can help ensure that electrical systems are safe, reliable, and efficient. It is also important to consider the potential for future expansion or modification of the electrical system. If the building is likely to require additional electrical capacity in the future, it is wise to install larger conduits and pull boxes than are currently needed. This will make it easier to add new circuits without having to disrupt existing systems. Furthermore, it is important to maintain accurate documentation of the electrical system, including as-built drawings and wiring diagrams. This documentation will be invaluable for troubleshooting and maintenance purposes. In conclusion, while the NEC does not explicitly prohibit running feeders and branch circuits in the same conduit, it is generally recommended to keep them separate whenever possible. This practice enhances safety, simplifies troubleshooting, and reduces the risk of interference. When it is necessary to run feeders and branch circuits in the same conduit, it is crucial to adhere to the NEC requirements, consider local codes, and follow industry best practices. By doing so, electrical systems can be designed and installed that are safe, reliable, and efficient. Following points summarize the key considerations discussed. Firstly, always prioritize safety when designing and installing electrical systems. Secondly, adhere to the NEC requirements and local codes. Thirdly, follow industry best practices and standards. Fourthly, consider the potential for future expansion or modification of the electrical system. Fifthly, maintain accurate documentation of the electrical system. Sixthly, separate feeders and branch circuits whenever possible. Seventhly, use appropriately sized conduits and conductors. Eighthly, direct conductor ampacity as needed. Ninthly, ground and bond conduits properly. Tenthly, provide adequate physical separation and identification of circuits. To recap, the NEC provides a framework for safe electrical installations. While it doesn't explicitly forbid combining feeders and branch circuits in the same conduit, it strongly encourages separation for safety and practical reasons. Understanding the exceptions and applying good engineering practices are essential for ensuring a reliable and safe electrical system.